Hello everyone. In this short video, we're going to illustrate how to use your personal computer, either laptop or desktop, to simulate Spark system and use sparklyr packages to leverage RStudio to learn how to use R on top of Spark. Before we go to the detailed demo, we'll need to install a few required software. First, you should have R installed in your computer. If you do not have R installed in your computer, please go to this address to download R. After you installed R successfully, please go to RStudio to download RStudio and then install RStudio. Please remember, RStudio do require you have R installed first. And the last piece is to make sure that you have Java installed in your computer. And if you do not have Java in your computer, you can go to the Java website to download for your computer. Okay, sometimes after when you installed Java, you may actually need to restart your computer to test whether Java is installed successfully or not, or if you have already installed Java in the past, we can do a quick test. The quick test is basically you open the command line window through the start and search CMD, and then this is your command line window. In this command line window, you can type in Java space dash version. If Java is already installed, then you're going to see the version information. Otherwise, you're going to see an error message mentioning Java is not kind of recognized as a program or something similar to that. So make sure you have RStudio and Java installed in your computer, and now we can use RStudio to simulate a specific Spark environment. So the next step is actually install the sparklyr package in RStudio, which requires to install more than 10 dependencies, and it will take a little while to install. So please be very patient. To illustrate the process, let's look at the RStudio. Alright, this is a brand new RStudio session, and to make sure we have the sparklyr library installed, we can actually check. If it is already installed, then it's going to load the package. The library sparkly is going to load the package. And also, it is a very important step. It's basically to first install a Spark version into your computer. So basically the Spark install version equal to 1.6.2. This step is actually going to install a local version of the Spark cluster for your own computer serve as the Spark cluster. So when you first install that, it may take a little while, so be patient. And because I already installed, so it's mentioned it's already installed. After the installation, you can create a connection. The connection is a very important step. Basically, the connection is going to connect your RStudio environment to the Spark environment. The Spark environment can be your local simulated Spark environment, or can be your enterprise level Spark cluster. And for this step, it's going to take a little while as well. And so please be patient. Wait for this Spark connection to be established successfully. So while we're waiting for the Spark connection to be established. Let's look at it. What is the difference between a master node and a Spark cluster? We can think RStudio is running on a particular computer node which has its own memory and CPU. And the Spark actually is a collection of computer node that is independent of your RStudio computer node that your RStudio is running. And the Spark cluster is basically a collection of computing node with their own memory and CPU. And Spark data frames are stored across Spark nodes. And the computation happens in the Spark cluster in parallel in nature. Okay, now let's check. Now the Spark connection has already established successfully and using the local master equal local option, which means RStudio connect to a local Spark cluster that is created by this Spark installation that we just finished a moment ago. And you can see that the Spark connection SC is basically create a variable, and in this variable we can see there are a lot of information regarding the connection. So we can basically view SC is basically the handle or pipeline between RStudio to the Spark cluster. Once we have the connection created, once we have the pipeline created, the next step is actually create some sample dataset and upload those dataset into the Spark cluster. And so far, there's nothing within the Spark cluster. So once you create a connection, you can see that the Spark UI here, there's nothing. So there's no data in the Spark cluster yet. To simplify the whole demo process, let's actually use the deploy_r library, and there are a few datasets that is already included. So let's load the deploy_r library, and then we're going to use the Aries dataset. The Aries dataset is a relatively small dataset, and this is the first few rows for the Aries dataset. There are 5 variables with a few hundred rows. And so Aries dataset is basically a data table that is in your RStudio local environment. So the next step is very important as well, which is basically to copy your dataset, in this particular case, the Aries dataset, to Spark environment through the pipeline we just created, which is called SC. And it is going to take a little while to copy the dataset into the Spark cluster. And once it finished successfully, you can see we created a Aries_TBL. This variable is a R variable, R object. So it contains a lot of information. Primarily, if we look at the value of those two variables, we can see that it is actually something related to a connection. So basically, the Aries_TBL is basically a handle that it is connected to the Aries table. This Aries table is no longer in your RStudio's kind of local computer, but it is already copied to the Spark environment. So this Aries table is actually part of the already stored in part of the Spark environment. So we can think this Aries table is stored across multiple CPUs and multiple computation nodes. And in reality, this table can be very large. And also in reality, in most cases, your data is already already stored in the Spark cluster, and what you need, actually you do not need to copy the data to the Spark cluster, and it is already there. And because we have this pipeline, we can actually see how many data tables in the Spark environment. So this is actually give us the currently there's only one table in the Spark environment, which is the errors table, and it is a Spark data frame. Once we know the errors table, which is a Spark data frame, and R can actually work on top of that through the handle that we actually link the errors table to the R studio environment. The R studio environment, the handle is errors_tbl. So whenever we do any operation on the Spark data frame, actually we're using the errors_tbl as the handle to access to that Spark data frame. And the sparklyr package is very useful because we can apply any of these functions in deployr to these Spark objects. So any of those functions that we can use typically in RStudio through deployr, we can now apply that functions into the Spark data frame arrays through arrays_tbl as the handle. So we can do simple things. For example, count the number of rows, and please pay attention to here. Even though we're using a errors_tbl, which is a R object in RStudio, but actually the operation of count is actually applied to the arrays table in the Spark environment. It is become a Spark data frame. We can count. We can also look at the first few rows in the Spark data frame, as well as do some data manipulations. And the advantage of using Spark data frame is we can leverage the Spark environment to process data that is very large, much larger than your memory or even much larger than your hard disk if we do have a very scalable large Spark cluster. And another advantage is we can still use the familiar RStudio operations defined in deployr to work on the Spark data frame. The combination of those two advantages make the big data analytics easily accessible to anyone who are familiar with RStudio. So in this particular operation, we actually did a few group by and summarize information, and then we created the new volume, the new column of the standard deviation for each different conditions that we define here using the group by function here. So if you are familiar with the deployr package, then you understand clearly what we have already done. But the advantage using sparklyr packages is we can apply the same kind of operation to a much larger Spark data frame. And sometimes once we finish the data manipulation in the Spark environment, we want to collect the data back to RStudio, and then we can use much more variety of packages that is available only in RStudio. So for example, ggplot tool. In ggplot2 provide a lot of plotting functions, and oftentimes we're going to do all the data aggregation and pre-processing in Spark. And once the data is ready, what we're going to do is going to collect the data back to the computation node that is running RStudio, such that it's become a local data frame in RStudio. In this particular case, arrays underscore summary is the local variable in RStudio. So you can see that we created a new data frame as arrays underscore summary, which is basically through a series operation, and at the end of this operation we collect the data, the processed data, into RStudio. And once arrays underscore summary is part of RStudio, we can do all different kind of operations in RStudio that we can do to leverage any data frame functions, such as the plotting functions. And now we are actually plotting the data out. One another advantage for leveraging Spark environment is we not only can do basic data manipulation and aggregation, we can also feed statistical and machine learning models to a Spark data frame. So in this particular case, the Spark data frame that we're going to work with is still the arrays data frame, and we can actually feed the regression, for example, linear regression, to this data frame by leveraging the handle that we created a moment ago. So the arrays underscore TBL is a connection to the arrays Spark data frame. And by using this connection and then call a linear ML underscore linear underscore regression function, which is one function provided by sparklyr, which basically is a wrapper of the linear regression function in the Spark environment. So this linear regression, the difference between this linear regression with the typical linear regression is the typical linear regression LM, for example, in RStudio, it can you only apply to a data frame that is in RStudio's environment. But this ML underscore linear underscore regression function can apply a linear regression to a Spark data frame arrays, and this data frame can be extremely large, like for example a few gigabytes of data. Is beyond the capacity of one local computer. And also the data is crossed through different kind of nodes of the Spark cluster, so the computation is in parallel in nature. So the sparklyr packages provide a very easy to use functions that is going to call the Spark's MLab library, which provide parallelized algorithm for many statistical and machine learning algorithms, such as linear regression, as well as k-mean method. K-mean is a clustering algorithm that it is widely used in machine learning, and luckily we can feed a k-mean cluster algorithm to the arrays data in the Spark data frame. And again, this data frame can be much larger than your memory in your local computer. And also the computation is parallel in nature. And for this particular case, we want 3 clusters and using 2 variables, and those are the fitted result. We can also predict the clusters from another data set. In this case, we're using the same data set. And again, similar to linear regression, sometimes we want to collect the data back um, to the RStudio's local computation node to leverage other functions to those data. So this is basically collect the prediction into a local R data frame. After running that, you can see that we do have a prediction data frame created. So those are the data collected from the Spark environment. Once it is in the RStudio's environment, we can easily run this function because it is already in your local RStudio's environment. You can do whatever you want using your typical RStudio knowledge. So in this particular, it's just simply plotting out using the ggplot function in the ggplot2 library. So that is the end of this simple demo. In this simple demo, we illustrate how to install the needed library for a illustration purpose of using RStudio to leverage the Spark system for big data analytics. Thanks for your attention, and hopefully this small video is going to help you understand how RStudio and the Spark system interact with each other and how to leverage Spark system to solve your big data analytics problem. Bye.